Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the temperature and pressure effect on physical and chemical adsorption. Okay, na? So in the last previous video, students, there also I discussed differences between physical and chemical adsorption. Okay, na? Just 3 points I discussed, but temperature effect, pressure effect, not discussed, students, because the video became already it is lengthy, so that's why I'm taking the second video, this temperature effect and pressure effect. Okay, Namma. So how the temperature and pressure affect in the physical and chemical adsorption, I'm taking the second video. Now see, students, in this section I'm going to discuss about the temperature and pressure effect. Okay, now see, students, temperature effect, physical adsorption. How temperature is affecting, temperature effect. Now see, Nana, temperature, how it is affecting the physical adsorption. Now here I am taking the graph between x by m versus temperature. What is x by m, students? It is the extent of adsorption. X by m indicates it is nothing but amount of adsorption. Amount of adsorption. Clear this one, amount of adsorption. This x by m, x by m indicates the amount of adsorption. In x by m, x is the mass of adsorbate, mass of the adsorbate, and m is equal to mass of adsorbent, mass of the adsorbent, students. Okay, Nama. So, adsorption versus temperature. What is x by m? Amount of adsorption. By increasing temperature, how much extent of adsorption takes place? In the case of physical adsorption, we know that in the physical adsorption, students, for example, this is the surface. I'm taking this is as adsorbent. Okay, now I'm taking here adsorbate molecules. Adsorbate molecules, students, these molecules are adsorbed, okay, on the surface of the adsorbent. Now between them, that is in between them, weak van der Waals forces are there. So are you clear this one? Adsorbent, so this is adsorbent, this is the adsorbate. Now see, students, here between the, this is which one? Adsorbate. Clear? So between the adsorbate and adsorbent, there is a weak van der Waals forces, students. Weak van der Waals forces. Whenever giving the temperature, students, when we are supplying the temperature when we are supplying, what will happen, students? Temperature increasing, what will happen? Whatever the weak bonds are there, these bonds will break, Nana. So these bonds will break, and these molecules can move away from the surface. Are you following? So these bonds will break between the adsorbate and adsorbent. Understanding, students, whenever giving the temperature, the bonds between the adsorbate and adsorbent, that is weak van der Waals forces, those forces, attractive forces, are breaking, students. So whenever breaking, what will happen? These molecules, Nana, move away from the surface. So that means here this is the adsorbent. Clear? This is the adsorbent. What will happen, students? These molecules are move away from the surface. That means like this, these molecules are move away from the surface. So bonds breaking between them. Are you clear this one? So that's why molecules move away from the surface, or adsorbate molecules move away from the surface, is nothing but adsorption decreases. That is nothing but desorption, students. Okay, Nama. So whenever giving the temperature, then what will happen here? What are the weak bond is there? Weak bonds are there. Bonds will break, and these molecules, adsorbate, is move away from the surface like this. Move away from the surface. So what will happen, students? This process is calling as adsorption. What this process is calling as desorption, students. What we will call desorption. What is desorption, Nana? Desorption means desorption means it is it is the process, students. In desorption, Nana, the adsorbate molecules are escape from the surface. Okay, na? So that process is calling as desorption. Clear this one? That means the molecules are move away from the surface is nothing but desorption. Okay, na? So that means whenever giving the temperature, bonds will break, these molecules are move away from the surface. That's why we'll call it as adsorption decreases. Correct or not? Here adsorption is there. Whenever given the temperature, these molecules are desorbed. That means they can escape from the surface. So that's why here amount of adsorption is decreases. Correct or not? Here adsorption decreases. So that's why what is the graph, students, in physical adsorption decreases. Na? So that's why graph will get like this. Clear, Nana? So this is the graph of physical adsorption, Nana, temperature effect. Now coming to the chemical adsorption, students, temperature effect. How temperature is affecting the chemical adsorption, temperature effect. Now see, students, how temperature is affecting. Now I am taking the graph between x by m versus temperature, students. So in this graph, whenever given the temperature, what will happen? Now see, students, we know that in the chemical adsorption, there is a strong chemical bond is formed between the adsorbate and adsorbent. Correct or not? So here this is the adsorbent. This is adsorbent, and here molecules I am taking. These are the adsorbate molecules. Clear? Adsorbate molecules. Now between them there is a strong chemical bond is formed. There is a strong bond. Are you following? So there is a strong bond, students. So whenever temperature is giving, now see, Nana, strong bond will be there. So that is a chemical adsorption. Now see, students, before adsorption, okay, na, temperature. Now see, students, before adsorption. Now I'm taking the before adsorption. Before adsorption, what will happen, students? Before adsorption, now these molecules don't have the threshold energy, students, to participate the chemical bond with the adsorbent. So we know that in the chemical kinetics collision theory, Nana, so the molecules are having the energy, but that energy is not sufficient to participate in the chemical collisions, chemical reaction we discussed. That means that means the energy is not sufficient to participate in the collisions. So we have to supply some external energy, students. Are you following? That energy is calling as activation energy. So the molecules are having the normal energy and activation energy, both add, then you will get the threshold energy. That means molecules, when they have the threshold energy, then only they can participate in the collision, students. Are you following? Then only they can form the bond between the they can form the product, Nana. Are you following? So that means here they should have the threshold energy. So first of all, these molecules don't have the energy. Now see, Nana, here I am taking the adsorbent. Now adsorbate. Now see, students, these adsorbate molecules are there. Now listen, these adsorbate molecules, they don't have energy to adsorb on the surface, or they don't have the sufficient energy. They don't have the threshold energy. Are you following? Threshold energy is nothing but the minimum amount of energy must possess by the reactant molecules to participate in the chemical reaction. So they should have the sufficient energy, students, to participate in the collisions. So that means here these molecules they don't have the much energy. So these molecules, they don't have sufficient energy. They don't have the threshold energy. Are you following? So that's why whenever giving the temperature, when we are supplying the temperature, students, supplying the temperature, what will happen? Whenever giving the external energy, this temperature or energy, it is helped to activate the adsorbate molecules. Are you following? Adsorbate molecules. That means we are giving the energy to the molecules, adsorbate molecules, to activate or to get the threshold energy, and they can participate in the bonding with the adsorbent. Are you following? So that means adsorbate can form the strong covalent bond. Whenever giving the temperature, whenever increasing the temperature, students, this temperature, that means we are giving the temperature, we are giving the energy to the molecules, adsorbate molecules, to activate, to participating in the bonding with the adsorbent. So they can form the strong bond, students. Are you following? So whenever a bond is formed between the adsorbate and adsorbent, a strong bond is formed. Clear this one? So that means how much how much energy is required, that much energy when supplied to the adsorbate molecules, then they can participate in the, that means they become activate, they will get the threshold energy, then they can form the bond. Students, are you following? They can form the strong bond. Okay, now see students, still when we are increasing the temperature, that means what will happen students, by increasing temperature, amount of adsorption increases, correct or not? Here, whenever given the temperature, these molecules are adsorbed, these molecules are adsorbed on the surface. Are you following? They forms the strong bond. Clear? So before they didn't adsorb, when we are giving the temperature, when we are giving the external energy, these molecules will get the sufficient energy to adsorb, then they form the strong bond. That means whatever the temperature we are giving, that temperature is used for the formation of the bond between the adsorbate and adsorbent. And after that, still when we are increasing the temperature, what will happen students? These bonds will break. Are you clear? Whenever increasing the temperature, so initially what will happen students, that whenever temperature increases, adsorption is increases students. Arthaita, whenever temperature increases, adsorption increases. Still further increase in the temperature, what will happen students? What will happen? The strong bonds also will break. Okay, now so whenever increase in the temperature, these bonds will break after that. So when bonds will break, again these molecules are moved away from the surface, they can escape. That means desorption takes place, that means amount of adsorption decreases, correct or not? So that means it is again decreases. Are you following? This is the graph. So initially amount of adsorption is increases students. Why here increases, Nana? During the formation of bond. That means we are giving the, when we are increasing the temperature, it is used to activate the molecules to participate in the bonding, Nana, to participating in the strong bond with the adsorbent. Okay, now that means adsorption is increases. When increase in the temperature, initially the temperature is amount of adsorption increases, and finally what is happening, still whenever increase in the more temperature, then what will happen? These strong bonds will break. Are you clear? This one, these bonds will break and these molecules are moved away from the surface. Are you clear? This one, these molecules are moved away from the surface. That means this is process is calling as desorption. Desorption means the molecules escape from the surface. That means amount of adsorption decreases. That's why it is decreased. Clear students? This is the temperature effect. Clear, Nana? So in the physical adsorption, see students, so whenever temperature increases, so what will happen in the physical adsorption? There is a weak bond, no? So already in between the adsorbate and adsorbent, there is a weak bond. So whenever temperature increases, these bonds will break and the molecules move away from the surface. Clear this one? So that is calling as desorption. That means amount of adsorption is decreases. That means they are moving away from the surface, means adsorption decreases. That's the graph is like this. In case of chemical adsorption students, whenever giving the temperature, because they have to form the strong bond, but in the case of physical adsorption, these molecules, they can easily form the weak bond with the adsorbent. Here the temperature is not that much applied. Are you following? That much not that much required, because less energy is only sufficient to form the weak bond. But here chemical bond should form. That means energy is not sufficient to form the chemical bond with the adsorbent. So that's why adsorbate molecules, what doing students, they don't have that much energy to participate to form the strong chemical bond with the adsorbent. So that's why whatever the energy we are giving at temperature and increasing, so what will happen, that energy is helped to activate the adsorbate molecules to participate or to form the strong chemical bond with the adsorbent. Are you following? So that means the whatever the energy we are supplying, that energy is helped in the during the formation of the chemical bond students. Are you following? So that means here bond is formed. That means adsorption is increases, correct or not? Whenever bond is formed, adsorption is taking place. Adsorption takes place, that means adsorption increases. So whenever giving the increase in the temperature increases, here amount of adsorption increases. After some time, what happens students? Here Still, when we are increasing the more temperature, what will happen? What are the chemical bonds formed between the adsorbate and adsorbent? These bonds also will break. Are you following? So temperature increases, these bonds will break. That means these molecules are move away from the surface like this. This option takes place. That means amount of adsorption decreases like this. So that means it is the case of this is the due to the breaking of bond. Here, why adsorption? Here amount of adsorption increases, students, during the formation of bond. So this is the case of formation of bond. Okay, the formation of a bond, here amount of adsorption decreases, adsorption increases, Nana. Adsorption increases. In this case, what, students? Breaking of bond. So during the breaking of bond, what will happen, students? Adsorption decreases. Are you clear? Adsorption decreases. Clear, Nana? Adsorption decreases. Here, till here, what happened? Bond formation, whatever the energy we supplied, that is helped in the formation of bond. So that's why amount of adsorption increases. Here, from here to here, what happened? Amount of adsorption decreases. Why decreases? Due to the breaking of bond. Breaking of bond, amount of adsorption decreases. Clear, Nana? This is the temperature effect. Now coming to the pressure effect. So finally, what we can say, students? Temperature effect, physical adsorption. Temperature increases, Nana. Temperature increases, amount of adsorption decreases, students. In physical adsorption, amount of adsorption decreases. What about chemical adsorption, students? Whenever temperature increases, that means initially what happens, students? In chemical adsorption, initially amount of adsorption increases and finally amount of adsorption decreases. Clear this one? So initially amount of adsorption, what happened? Amount of adsorption increases. Why increases, students? Due to the formation of chemical bond. ಅರ್ಥಾಯ್ತಾ? Formation of chemical bond, Nana. Okay, next, finally what happens, students? Finally, whenever increasing more temperature, what will happen, students? More temperature. Okay, what will happen? Bonds will break. Correct? Bonds, chemical bonds will break. So bonds are breaking, students. So bonds breaking, then desorption takes place. Okay, na? Desorption takes place and amount of adsorption decreases. Amount of adsorption decreases. Clear this, students? Amount of adsorption decreases. Okay. Now I am going to discuss about the pressure effect, students. How the pressure is affecting. Pressure effect in physical adsorption. Pressure, how it is affecting. Pressure effect. Now see, students, the graph is drawn between x by m versus pressure, students. Pressure effect. Amount of adsorption. Now see, students, if I take the less concentration of the adsorbate, suppose this is the adsorbent. Okay, this is adsorbent and these molecules are what, students? Molecules are adsorbate. Okay, adsorbate. So here I am taking the less number of molecules, less number of moles. Okay, then what will happen? Less number of moles are there means pressure, they exert the less pressure, students. They can collide with one another, they can produce the pressure. So because of that pressure, what will happen, students? Amount of adsorption increases, Nana. Correct or not? Amount of adsorption increases. Whenever increasing the number of moles, still what will happen? So number of moles are increasing. More number of moles I am taking. Are you following? So here only less number of moles. I am taking here less number of moles. Clear? Less number of moles of molecules when we are taking adsorbate, in between the molecules collisions are taking place and they can produces the pressure, they can exert the pressure. Plus because of that pressure, what will happen, students? Amount of adsorption increases. Whenever increasing the number of moles, number of molecules I am increasing, okay, now adsorbate molecules I am increasing, students, then what will happen? Whenever increasing the number of molecules, they exert more pressure. Are you following? They can collide with one another, they can exert the more pressure. So because of more pressure, what will happen? Amount of adsorption also increases, students. That means these all molecules can easily adsorb on the surface. And it is already, we know that it is a multi-layered, correct or not? It is a multi-layered. That means in between the adsorbate and adsorbent there is a weak bond. So another layer part, another particles also, they can easily push that molecule and they can enter, they can occupy at the surface of the furniture, students. Are you correct or not understanding? Because there is a weak bond kada, there is a weak bond between the adsorbate and adsorbent. So whenever increase in the molecules, it is a multi-layered kada physical adsorption. So that's a more number of molecules can easily adsorb on the surface. Because why Nana? Because there is a weak bond. So that's if suppose this molecule want to form the bond with the surface, that means what will happen? This is pushing these molecules and it is can enter into the it can occupy the surface. So that's why we can say that amount of adsorption is increases, students. Clear this one? Increases means the graph is like this. Okay, now coming to the pressure effect in the case of chemical adsorption. What is the pressure effect? Now see, students, what is the pressure effect? Now graph, if you see Nana, in chemical adsorption graph is drawn between x by m versus temperature. Now here what is the graph, students? See here, if I take the less number of molecules, suppose I am taking this is adsorbate, less number of molecules means they can exert less pressure is less, correct or not? Pressure is less. Okay, that means adsorption increases, students. Okay, now I'm increasing the number of molecules, students. I'm increasing the number of molecules. Okay, number of molecules I'm increasing. So but we know that here, once this complete surface of the adsorbent is filled with adsorbent, it is completely filled with, when it is completely filled with adsorbate molecules, students, okay, now adsorbate molecules, then other molecules cannot easily enter or cannot easily occupy the surface, students. Are you following? Because they forms the strong bond, Nana. Here what happened, there is, they can form the weak bond. So that's why these molecules, they can easily push these molecules and they can occupy easily on the surface of the solid. But in this case, students, more number of molecules are there, they exert more pressure. Even though what will happen, once the surface of the adsorbent is completely occupied by the adsorbate molecules, then other molecules cannot occupy on the surface of the adsorbent, students. How much you have applied the pressure also, they cannot adsorb, because due to the lack of surface area, because already they have the strong chemical bonds, so they cannot move. So when these molecules, if they try to come and occupy the surface, but they cannot move, students. So that's why, due to the lack of surface area, first initially the amount of adsorption increases, okay, now increases. But here what happened, whenever increasing the number of moles, once the surface is completely adsorbed, completely occupied by the adsorbate molecules, these are all adsorbate molecules, what will happen, students? These molecules cannot occupy the surface, students. That means due to the lack of surface area, what will happen? Amount of adsorption is remains constant. Are you following? Here how much adsorption is there? Still when we are increasing the number of moles, also number of moles increases, pressure also, they exerts more pressure. Okay, they exerts more pressure, students. I told number less number of moles, they exerts less pressure. Are you following? Less number of moles exerts less pressure. Clear, Nana? Exerts less pressure. More number of moles exerts more pressure. Are you following? Exerts more pressure, students. more pressure. So here more number of moles applied, but here what happened, once the surface is completely filled with adsorbate molecules, remaining molecules they cannot occupy, students. That means amount of adsorption remains constant. Understanding? So adsorption is remains constant. Like this graph you will get. First initially it is increases. Are you following? Adsorption increases. Whenever increase in the number of moles, what will happen? These molecules cannot occupy, because already the surface is completely filled with adsorbate molecules due to the lack of surface area. So why here adsorption is constant, students? How much increase in the number of moles also? Here adsorption is constant, students. It is remains constant. Okay, adsorption is constant. Why, students? What is the reason? Due to the lack of surface area. Due to the lack of surface area, students. That's why the amount of adsorption remains constant. Are you following? The graph is like this. Here increases, here remains constant. Clear this one? It is remains constant. Clear this, students? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, Lana. Thank you very much, students.